Bismillahirrahmanirrahim. Assalamualaikum and hi everyone. My name is Siti Fatehah binti NORDIN. My matrix number is 1210582 and I am from KSC1. Today I will present one of the topic of discrete mathematics, which is relation. Before we start, this presentation consists of three parts, which is introduction, example on relation, and conclusion. There are many kinds of relationship in our lives. As example, friendship, marriage, classmate, and family. Similar in mathematics, elements can be related in various ways. Set A may be said to be related with set B if A is a subset of B. But if A is not a subset of B, A and B can be related if set A and B have at least one element in common. Before we move to the definition of relation, let's see the definition of Cartesian products. Cartesian products is set of all possible ordered pairs with first element and second elements, which is x cross y equals to xy, x element of x and y element of y. This is also called as Cartesian product of x and y. Never mind, I will explain about it later with more examples. So, what is relation? Relation can be described as a collection of ordered pairs, which is used to relate an object from one set to the other set, and the sets must be non-empty. The relation can contain two or more than two sets. To make it interesting, I found an example of relation and Cartesian products from a boy group, a Korean boy group that is famous because of their multi-talented members, which is, can you guess it? It is NCT. NCT contains of 23 members and 4 units, which is NCTU, NCT127, NCT Dream, and Wavy. So I will brief a little bit about NCT127 and NCT Dream. NCT127 members is from here to here, while NCT Dream members is from here to here. So obviously you can see that two of the members of 127 is also the members of Dream, right? Okay, let's. So the example of today is NCT Dream. So to remind you again, Mark and Hee-chan also the members of 127. So as we have learned the definition of Cartesian products, let's see how to answer a question regarding Cartesian product. The example, okay, so write Cartesian product for x cross y. X is the members, y is the unit. So the ordered pair is xy. xy, x element of members, y element of unit. So the answer is this, according to the order xy, which is Mark Dream, Mark 1 to 7, Hee-chan Dream, Hee-chan 1 to 7, Rongjun Dream, Rongjun 1 to 7, Zeno Dream, Zeno 1 to 7, Jamin Dream, Jamin 1 to 7, Chandler Dream, Chandler 1 to 7, Jisun Dream, Jisun 1 to 7. So that is the answer for the first question. So next, y cross x. Write the Cartesian product for y cross x. So y is the unit and x is the member. So unit cross members. The ordered pair is yx, yx, and y is the element of unit and x element of member. So just do as usual as above. So let's see the definition of Cartesian product again, if we have understand it. Set of all possible ordered pairs, set of all possible ordered pairs with first elements and second elements. So that's it. So let's see the definition of binary relation. A binary relation R from a set X to a set Y is a subset of the Cartesian product of X and Y, which is X cross Y. If X, Y elements of R, we write X, R, Y, which is X related to Y. If X equals to Y, we call R a binary relation on X. Okay, let's see. Let R be the subset of A cross B means R is a set of ordered pairs of the form AB. R is a set of ordered pairs of the form AB, where A elements of A and B elements of B. We use the notation A related to B to denote AB elements of R and A not related to B to denote AB not elements of R. If A related to B, we say that A is related to B by R. Okay, let's see example. Let A equals to ABC and B equals to 1, 2, 3. Okay, so the first question is R equals to A1, B2, C2 a relation from A to B? So from A to B, A1, A2, A3, B1, B2, B3, C1, C2, C3. So the answer is these elements from the Cartesian product of A to B? Is this the relation from A to B? Yes, the answer is yes. So the second question is Q equals to 1A, 2B a relation from A to B? From A is only ABC and B is 1, 2, 3. The answer is no. Why? Because this is a relation from B to A. Third question is P equals to AA, BC, BA a relation from A to A? The answer is yes, because the element of A relation to A is AA, AB, AC, BA, BB, BC, CA, CB, CC. Okay, so as I have mentioned earlier, Mar and Hechan are the fixed member of the unit 1 to 7 and also DREAM. So let's see how to answer this question. X cross Y, the relation is fixed member of the unit. X cross Y member times unit. XY is element of R. So equals to Mar DREAM, Mar 1 to 7, Hechan DREAM, Hechan 1 to 7, Ranjan Jana Jamin Chanlajistun DREAM. So the answer is XY. The order is still XY. X related to Y, which is XY elements of R. So if the question asks about consists of member of unit 1 to 7. The answer is Mark 1 to 7 and Hechan 1 to 7. The condition here and here define what is the relation. Okay, let's see the definition of relation again. Relation can be described as a collection of ordered pairs. It is used to relate an object from one set to the other set. From one set to the other set, and the set must be non-empty. The relation can contain two or more than two sets. So relation is two sets. So relation have three diagrams to represent relationship. The first one is direct, bidirectional, and relate to itself. So there are three properties of relation, which is reflexive, symmetric, and transitive. Reflexive. Okay, so as I mentioned before, there are a diagram to represent a relationship, which is arrow to itself. This is for the reflexive, which is for all elements X, the ordered pair X, which is the X arrow to itself. So for the symmetric, arrows back. Okay, as I mentioned before, it is bidirectional, which is if X, Y, then Y, X. If X, Y, then Y, X. It is symmetric. So next it is transitive, shortcuts. So for the shortcut is, okay, let's imagine this. X to Y, okay, if you can see X to Y, let me use another color, maybe. Okay, wait, X to Y, and then Y to Z. So the shortcut, okay, let's see, X to Y, Y to Z, like this, right? And then the shortcut becomes X to Z. So that is the transitive. So the conclusion for today's presentation is relations are important concept in set theory and operation. It is useful during creating functional analysis and relational database, and it is also useful in our daily lives. So this is my references. I think that's all for today. Thank you for lending your ears, and Assalamualaikum. Stay safe.